For thousands of years, people have looked up at the night sky and wondered, are we alone? Theory suggests that planets form out of the so-called debris disk that's left over once a star is ignited. But the question is, how does life form and where should we look for it? There are three things that people agree on that life as we know it need to exist. First is liquid water. The second is the conditions that are inducive for the formation of large complex molecules. And the third one is some sort of energy source to sustain metabolism. Now, if you take any star, I'm showing here our solar system, and there's a well-defined distance away from that star where liquid water can exist. At the inner edge, just below boiling point, and at the far edge, just above perpetually being frozen. For our solar system, that so-called habitable zone stretches from just inside the orbit of Venus to outside the orbit of Mars. Now, the surface of Venus today is far too hot to have any liquid water on it. In fact, it's hot enough to melt lead, and that's because of a runaway greenhouse effect that's going on Venus. On the Earth, we know that there is life. We can have an interesting debate later on whether it's intelligent or not, but we know that there's life on the Earth at least. So let's focus a little bit on Mars, since it's still inside the habitable zone of our sun. In 2004, NASA sent two rovers to Mars, Spirit and Opportunity, and they were supposed to go there and see if we could find conclusive proof that water ever existed on the surface of Mars. Well, within a very short period of time, they both identified minerals that we on Earth associate with water and that are formed in the presence of water. So, in a very short time, we knew that there must have been water on the surface of Mars sometimes in the past. But today, of course, the surface of Mars, as you can see, is pretty dry and much like most of the deserts on Earth, and even drier than that. So NASA decided to go back there, in fact, in 2012, with a larger and more sophisticated rover called Curiosity, and look to see if we could determine if the conditions on Mars was ever such that it could have sustained life. So, in August 5th of 2012, we arrived at the top of the atmosphere. I see the video is not playing here, unfortunately. I guess another one of those PC to Mac translations. Maybe some of the entrepreneurs here can figure out how to solve that problem for us once and for all. But nevertheless, we landed in a spectacular fashion on the surface of Mars in August 2012. If you want to see the details of it, I suggest you go Google 7 Minutes of Terror and you can watch it yourself. Suffice it to say that we had to land a rover that weighs 1 ton on the surface of Mars, arriving there at 13,000 miles an hour, and in 7 minutes we were supposed to slow down and gently land on the surface of Mars. If we did not gently land, we would have met some interesting people in Washington, I'm sure. But you know that that was a spectacular success, and this is what the surface of Mars looks like in Gale Crater, where we landed with Curiosity. Now, as I said, the job of Curiosity was to go there and determine if the conditions were ever such that it could have sustained life. This rover carries 10 very sophisticated instruments. It's actually a roving chemistry lab, if you want to. It carries a drill, as you can see in the upper right in the slides there. And with that drill, we drilled the first two holes ever drilled on another planet. You can see the two holes there, taken a picture of it on Mars. We scooped up some of that gray material up and analyzed it further. Now, by the way, you will notice that the surface of Mars is this brownish reddish color. It's called the red planet for that reason. But the interior of that rock is gray. This in itself is already a major discovery. People thought that this dead, rusted zone, if you want to, on Mars extends several meters into the surface. And here you can see we only drilled 2 centimeters into the surface and we're already in fresh material. In any case, we analyzed that material and it clearly showed that the conditions in Gale Crater were indeed such that life could easily have existed there. In fact, there was water for at least 1,000 years in this area, and the water was of such a quality that if you and I were there, we would have been able to drink it. In what is more, all the major minerals and so on that are required for life were indeed present in this area. So the big question then is, if it was habitable at one point in time, what happened? Why is it now so dry and barren as you saw in the previous slide? Well, for that, we are driving to the mountain called Mount Sharp, which is a 3,000 meter high mountain that is layered in terrain. So the oldest rocks in the bottom are old and of more or less the same period as the area that we analyzed. And as we drive up the mountain, we will encounter younger and younger rocks. And the hope is, as we analyze those rocks, we'll be able to tell when in the history of Mars did the conditions change from the wetter and more life-like conditions to what it is today. But as you can see, not everything is easy on Mars. When you're driving around up there, if you look very carefully, you will even be able to see some holes in the wheels of Curiosity. Now, when the nearest tire shop is a couple of 100 million kilometers away, you have to be very careful what you do with this rover. And we at least figured out which kinds of terrain to avoid, the kinds that would poke holes in our wheels like that. And here you can see the tracks across a little sand dune on our way to the mountain. The mountain is visible just in the upper right corner there, and pretty soon we will start driving up the mountain, hopefully in the next couple of months, and start hopefully get some of those answers. But I want to challenge you to look beyond Mars. Let's look at outside of the habitable zone of our solar system, and let's move on. Oh, first I forgot. There's a tantalizing evidence actually from orbit. Some of our orbiting imagers have taken this series of images of Mars, and it clearly shows those streaks forming in the beginning of the Martian summer and then disappear again at the end of the summer. The theory is that in this area there's ice close enough to the surface on Mars that during the summer months, when it gets warm enough, the ice can actually melt and form those briny water seeps that you see there. So we know for now that there is, in fact, water on the surface of Mars. It doesn't pond like it is on the Earth, but it's close enough to the surface that during the summer it can actually melt. We also know that there are caves on Mars. These are pictures taken from orbit of a couple of entrances to caves. So if you have moisture near the surface and you have caves, maybe inside those caves we could find environments where life could exist. But of course you can't drive a rover into one of those caves. So we have to figure out some other ways of entering these caves, and we're working on things like this, a little gecko rover that can climb upside the ceiling of a rock surface like that and climb upside down, and you can imagine how much fun people are having in the labs with these kinds of things. So hopefully in the future we'll be able to go explore some of those caves. But like I said, let's move outside our habitable zone and look a little bit near Jupiter. Jupiter is the largest planet in our solar system, 5 times as far away from the sun as the Earth is. And let's particularly look at the moon called Europa. If you look carefully at this image, you will notice there's only really evidence of one crater near the bottom part of that moon there. That indicates that the surface is relatively young, but the moon itself isn't young. So what's going on? Well, the theory is that the entire moon is covered in a crust of ice, and that crust is a couple of tens of kilometers thick, and that ice, more importantly, covers a global ocean, an ocean that by some estimates is as deep as 60 kilometers. Now, the Earth has a large ocean, but it is only a couple of kilometers deep. So when you have a moon about the size of our moon with a 60-kilometer deep ocean, it actually has about as much, slightly more water, in fact, than the Earth itself. So Europa may actually be the place in our solar system with the most water on the moon. So this is an area that we would definitely like to go back and take a look at. And in fact, NASA is working on a mission concept called the Europa Clipper to go there and try and estimate whether there is indeed an ocean, use high-power radars, for example, to penetrate through the ice to see if there's indeed a global ocean underneath that ice. So moving even further away to Saturn, 9 times as far away from the sun as the Earth is. The spacecraft Cassini arrived there in 2004. And during its tour of many moons of Saturn, Saturn has 60 moons, but this one in particular, which is about 300 miles in diameter, Enceladus, we noticed these interesting plumes coming out of the bottom of that moon. So we challenged our navigators to bring us as close as possible to the moon so we could see some more details of those plumes. And they actually flew about 16 miles above the surface of that moon, right through some of those plumes. And those plumes are actually water vapor that are spewing up about 150 miles or so in the air above that little moon. And here you can see a close-up. And again, if you look in the northern part of the moon, you will notice that there are a lot of craters in there, but the southern part of this moon is smooth. Again, that indicates a younger surface. In this case, the theory is that the southern part of it has a ocean or a large lake, if you want to, underneath the ice crust again. So this one is also a place that there's a good chance that there might be at least the conditions to find life. But as I said, it's 9 times as far away from the sun as the Earth is, so it's a little bit more of a challenge to get back there. But I'm sure in the future we will go investigate this again. But what about outside of our solar system? When I started the Jet Propulsion Lab working with NASA in 1986, not a single planet outside of our solar system was known. In fact, the first planet was discovered in 1994. To give you an idea how hard it is to make a good picture of the Earth, if you take the Earth and you put it around the nearest star to the Sun, only 4 light years away, and you want to make this crappy picture of the Earth, you will need a telescope about 15,000 times the size of the Hubble Space Telescope. So that is a tremendous, difficult feat to do. So no wonder I gave up on working on this telescope designs in 1986 and went and did something else for a while. But there are indirect ways in which you can find a planet. And if you look at this particular cartoon, if that planet were to revolve around its sun, and it comes in between us and that star, it will block out a little bit of the light from that star. So if we were to be able to stare at that star all the time, and we would notice every once in a while the star goes slightly dimmer for a couple of hours, 10 to 18 hours, depending how big the star is and how fast the planet is moving, and then it comes back up bright again, and this happens regularly, then we know that there is something that is orbiting that star, and by how much it dims, we can tell how big that object is. NASA built a 100 megapixel camera that we launched in 2009 called Kepler. And in only 3 years of operation, Kepler has found 3,845 candidate planets around other stars. That's as of this month. 962 of those candidates have been confirmed to be planets. Kepler stares at exactly the same 150,000 stars all the time, looking for how they dim and then come bright again. And if you take the statistics, remember, we can only see those planets if they come between us and the star. But if they go around the star like this, we would never see them. And if you assume the orbits are random and so on, then you will calculate that there might be as many as 500 billion planets only in our galaxy. And of those, more than 500 million of them would be in the habitable zone of their stars. So we don't look so special anymore. But did we find anything that's remotely like the Earth? The answer is yes. We found 1 planet so far. Kepler 186f. Well, we're not very imaginative in how we name these things. It's the 186th object that we looked at, and F means it has 5 planets. Now, this 5th planet that was recently discovered and announced is in fact in the habitable zone. It is almost exactly the same size as the Earth. The only difference is its sun is about 1/10 the size of the Earth. It's an M dwarf, a so-called M dwarf star. But nevertheless, it is in the habitable zone and it's about the same size as the Earth. So we know of at least 1 other planet out there that could be like the Earth. I say could be because all we know at this point in time is what its orbit is, how far away it is from its star, and how big it is. We do not know anything about the atmosphere yet. That is the next step, to analyze the atmospheres of these planets and see if we can find the signs of life, those kinds of gases that you would typically associate with biologic activity. So are we alone? I don't know. I'd like you to be the judge of that. All I can say is I hope that in my lifetime somebody would find some signs of life somewhere else. Thank you very much.